Welcome to Garvit Sharma online classes. Today we will learn about theorem number 2 and theorem number 3. This is the video which will help to the students to solve theorem number 2 and theorem number 3 of your chapter number 8. This is class 9th chapter 8. Theorem 2. What is theorem 2? First of all, we try to understand what is the theorem 2. The theorem 2 is saying that a diagonal of a parallelogram divides it into two congruent triangles. Any parallelogram, diagonal of any parallelogram divides it into two congruent triangles. We have to prove it. Let's take a parallelogram ABCD, A, B, C and D. Take its diagonal AC. Its diagonal AC divides it into two congruent triangles. We have to prove that triangle ABC congruent to triangle ADC. It is D. Yeah. Theorem 2. First of all, we have to write given. What is given in this theorem? In parallelogram ABCD, in parallelogram ABCD, AB parallel CD, AD parallel BC and AC is diagonal. AC is diagonal. To prove, what we have to prove? We have to prove triangle ABC congruent to triangle ADC. Let's give the name of these angles 1, 2, 3 and 4. Here 1, 2, 3, 4. Yes. Now we prove it. In triangle ABC, in triangle we take two triangles. Triangle 1 is ABC and triangle 2 is ADC. In triangle ABC and triangle ADC, angle 1 is equal to angle 4. Angle 1 is equal to angle 4. Alternate interior angles. Alternate interior angles. We use here abbreviation of alternate interior angles AIAs. And take side AC is equal to AC, which is common. AC is equal to AC common. Angle 1 is equal to 4. Yeah. Now we will write here angle 3 is equal to angle 2, which is also alternate interior angles. Yeah. Therefore, triangle ABC will be congruent to triangle ADC. By how? By angle side angle. By angle side angle property. We have proved that ABC ADC congruent. Here. Now we look theorem number 3. Now we look theorem 3. Theorem 3 is in a parallelogram, opposite sides are equal. Same thing, in a parallelogram, opposite sides are equal. Figure will be same, but different is that AC diagonal is not given. We have to construct it. We have to construct it. Theorem. Yeah, here is spelling is theorem 3. Theorem 3 yes, look at theorem 3. In a parallelogram, opposite sides are equal. In a parallelogram, opposite sides are equal. Given. What is given? It is given only in parallelogram ABCD. AB parallel CD and AD parallel BC. To prove what will we have to prove? What will have to prove? We will have to prove that AB is equal to CD and AD is equal to BC is equal to AD. Opposite sides are equal. These are the opposite sides. We will have to prove that it will be equal. The pair of opposite sides will be equal. Construction. We use here construction because diagonal is not given. We use here construction because diagonal is not given. Join AC. Yes. Proof. Its proof will be same. First of all, we should congruent ABC to congruent ADC. In triangle ABC and triangle ADC. In triangle ABC and ADC, angle 1 is equal to angle 4 by alternate interior angles, and AC is equal to AC, which is common. Angle 3 is equal to angle 2, which is alternate interior angles. Therefore, triangle ABC will be congruent to triangle ADC. By how? By angle side angle property. And so AB will be equal to CD and BC will be equal to AD. But how? Both of these will be equal by CPCT, corresponding parts of congruent triangles. Corresponding parts of congruent triangles. Hence, we have proved both of AB is equal to CD and BC is equal to AD. Like, subscribe and share my video. I will come back with my next video and remaining theorem.